if you have a bunch of different terms, it doesn't matter what they are. You have a bunch of different terms, and then you take the product of all of those. If the product equals 0, the only way that could have happened is if one of those original terms was 0. There's no way that you can multiply two numbers and get 0. The only way for that to happen is if one of those is 0. Does that make sense? So that's what this rule states. And so I'm going to try to put it as brief as possible. But so I'm going to say that if the product of two or more terms is 0, then one of those terms must be 0. If the product of two or more terms is 0, then the only way that can happen is if one of those original terms was 0. So the reason that's important right now is because we have the product of two values. This is our first value, x plus 10. This is our second value, x minus 0. X minus 30. And apparently, when we take the product of these two, it equals 0. That's what the problem says in your book. So, one of these quantities has to be 0. That's the only way it can work. So, two things can happen. Either, I'm going to go back to strictly black ink, x plus 10 equals 0, because if that's the case, if this was 0, then 0 times anything, it does not matter what's in this set of parentheses, 0 times anything would be 0. Or this value, this quantity in this set of parentheses, this has got to equal to 0. Because if this equal to 0, it does not matter what is in this set of parentheses. 0 times anything is still 0. So what I've done is I've applied the zero product rule, and I've broken this up into two separate equations where either x plus 10's got to equal 0 or x minus 3 is equal to 0. So I've got, in the end, x is equal to negative 10, or x is equal to positive 3. Now I've solved this equation. Now I have given a value of x. And so x is negative 10, or x is 3. And you can always check your answer. Again, why not check your answer? Let's say we plugged in negative 10 to our original equation. Well, if we did this correctly, if I plug in negative 10, it better equal 0. So I have negative 10 squared plus 7 times negative 10 minus 30. That should equal 0 if we did this correctly. What's negative 10 squared? Positive 100. Because a negative 10 times a negative 10 is a positive 100. And then I have a 7 times a negative 10, that gives me negative 70. And then I'm subtracting 30. Does 100 minus 70 minus 30 equal 0?
Yes.
Yes. So I know that I did that part correct. Let's see if the other value works out, which is positive 3. So positive 3 squared plus 7 times positive 3 minus 30. Hopefully, if we did this correctly, it should equal to 0. 3 squared is 9, plus 7 times 3 is 21, minus 30. Does 9 plus 21 minus 30, does that truly equal 0?
Yes.
Yes, then we did solve this correctly. We keep referring to this equation as a quadratic, but we've yet to talk about what it looks like graphically. If we were to type this into our calculator, what would it look like? It's a parabola. In parabola, those look like the U's. That's what a parabola is. In this class, I hope, my hope in my endeavor is to have meaning with these concepts and this mathematics. And I hope I've held true to that. And I hope that once we talk about geometric concepts, I hope that I explain it to you. I don't want some process that means nothing to you. I don't want you guys to be robots and you just keep following the same series of steps and spitting out numbers that you have no idea what these numbers mean. Mathematics should have meaning to you. So where the significance of these values is, this is an equation, right? And just like all equations that you type into your calculator, we put it so that y is solved for. So we have y equals something. And we've been dealing with like a lot of linear equations, and so those were in slope-intercept form, where it was y equals mx plus b. But this is a quadratic, and so right now I have y is equal to x squared plus 7x minus 30. And when I graph this, whether that's on the calculator or wherever it may be, it's going to be a U-shaped. And it's going to look something like this. Something like this. And the significance of these values is, when we set it equal to 0, well, y equals whatever. When we set it equal to 0, we're saying what's happening when y is equal to 0. What are my x values when y equals 0? On the graph, where are all the points where y is 0? Where is that located on the graph? Where all of the y coordinates of the points are 0. It's your x-intercepts. It's any point on the x-axis. If I choose any point on this x-axis, doesn't matter where, its y value would be 0. So when you take this equation, you set it equal to 0, you say, what is x when y is 0? You're really asking, where does it cross the x-axis? What's the value of x when it passes through? So that's the significance of setting these quadratics equal to 0. And so if you graphed it, it would pass through at x equals -10. That's why I drew it way out here. So this value is -10. And it would also pass through at +3. That's where it crosses through the x-axis. Yes, sir?
So when you're given one of those problems and you're putting a calculator and you look at the table, you just take them out like that?
I need to see this. You need to know how to factor quadratics and apply the zero product rule. You can gladly check your answer, yes. But I need to see you factoring quadratics and you solving for the true values of x. You should get... Sometimes when the vertex of the parabola is on the x-axis, there will only be 1, 0 is what we call these, or roots. Then, what you're going to see in Algebra 2 is sometimes these parabolas won't even cross the x-axis. That's where imaginary numbers come into play. And we've talked about those before. There are imaginary numbers, and the reason they came up, or one of the applications, is because when parabolas do not cross the x-axis, they swoop down and they never cross. Those have imaginary roots. So, what is the problem on 2a? What is the quadratic that was given to us? Okay, I think I heard x squared minus 8x plus 15 equals 0.
Yep.
Awesome. So we need to first factor this. So we gotta do first is factor this quadratic. So we need to figure out x plus or minus something and x plus or minus something. Now let's break this down. And again, I want this to make sense to you. I don't want this to be some mundane process that you keep going through, but there's meaning to it. There are huge significance of these plus or minus symbols. We know that these two values need to have a product of positive 15 for this example. But the fact that it's a positive number, what does that tell us about our two values here?
Both negative.
Say that louder. They're either both positive or they're both negative. They have to have the same sign. It's either going to be negative number and negative number, and when you take the product, it's going to be positive, or it's positive, positive. So that's very significant. We know that the signs need to be the same. Now that we know the signs need to be the same, let's look at this. Their sum is a negative 8. So that tells us even more information about these two values we're searching for. That tells us what about these two values? What's up, Gideon? They have to both be negative. So you can go into it knowing that, okay, since it's positive, they got to have the same sign. Well, since that's negative, they both got to be negative. So what two negative numbers, product will be positive 15, but sum will be negative 8? Negative 3 and negative 5. So negative 3, negative 5. You can always check your answer and make sure that if you take the product of these two binomials, that it truly does equal that quadratic, but it's right. We'll just keep going on, but it's good to check. For time's sake, we need to move on. But I'm not done. The second step is to apply the zero product rule. Which means, since I know that this binomial times that binomial is 0, one of them has to equal 0. So we're going to separate and break up and set these two binomials equal to 0. So I've got x is positive 3 as one of my answers, and x is positive 5. Now in your calculator that everyone should have right in front of them, I want you to type this quadratic into your y equals charts. Please type that equation into your y equals chart. To access your y equals table, you hit this. Oh, I'm sorry. This button right here. It says y equals. Should pull up a chart like that, and we're typing in x squared minus 8x plus 15, and when you hit graph, there it is. So when we just solved that, we got x is equal to a positive 3 and a positive 5. Because those are the roots, those are the zeros. That's where this graph will cross the x-axis. Those are the x values. As you can see, this is 1, this is 2, 3, 4, 5, 6, 7, so on and so forth. So right there, 3, positive 3 and positive 5. But I need to see your work of you factoring quadratics and applying the zero product rule. The process is more important than the answer. I need to see that. But having meaning with this process is even more important. So any questions about factoring quadratics or solving these quadratics when set equal to 0? Yes?